Okay, good day. This is Mr. Stolle. Now, today we are looking at analytical geometry. Now, analytical geometry, here we'll be dealing with distance between 2 points, and we'll be dealing with gradient, midpoint, what is it else? Angle of inclination, collinear points. Those are things that we'll be actually looking at actually today. Okay, so here when I'm given 2 points here, like from 0 to T, and we see that we want to find R. And in this case now, this is more like our hypotenuse that we need to find here. And we have this side as our opposite, and this one is our adjacent. So we know how we find this. For us to find OT, we will say this is OT squared. We will say it is equal to X, which is, what is it? Like opposite here, it's Y squared plus X squared. That's what we're having here. But now, how do we get this Y squared? Maybe just rub here. It's Y minus 0 squared plus X minus 0 squared. Then in this case now it's going to give us OT is going to be a root. When you are moving the power there, it's going to be Y squared plus X squared. Now let's check here what we need to understand in terms of if we are to find PQ, the general formula for distance, PQ. Now, since now we have got 2 points now, this one is not all the origin. So what do we need to do here? We know that we're going to say this is going to be equals to root of XP minus XQ, sorry, XP minus XQ. You square that plus YP minus YQ. We square that. That's how we find our distance. So let's try to find if we can see if we can find this or this of AB. So AB is equals to root of XB minus XA squared plus YB minus YA squared. Then what do we have here? Put our root again. What do we have? We have got 5 XB is 5 minus, and it's minus 4 squared plus 7 minus 3 squared. Okay, then let's see what we get there. As you can see here, this is minus going to give us plus, minus going to give us plus. So we're going to put our root, root in bracket 5 plus 4 squared plus 7 plus 3 squared. What do we get? We get root 181, root of 181. So you can leave your answer like this. If it's not, if they it's still fine like this in set form, or you can put it 2 decimal places. So it's gonna be equal to 13,45. Okay, so whichever way, either 2 decimal places or in set form like that. Now let's try to find midpoint. So the midpoint, let's just come down here and find the midpoint of A, B, okay? What do we know? We know that it's equals to XB plus XA over 2. That's how we find the coordinate, the X coordinate, and the Y coordinate you find it by saying YB minus YA over 2. That's how we find the Y coordinate. Now let's check here. What is our XB? Our XB is 7. What is our XB? Sorry, it's 5. So your coordinates, you start with the X. x that you count on the x-axis, okay? Then it's what is it? It's -4, our xb, plus 5/2. It's the midpoint. Then here it's going to be -3 plus 7/2. Then what do we have here as our answer? -4 plus, we're going to get 1/2 in terms of x. Then negative plus 4/2, it is going to be equals to 2. So we have got half. So it's going to be somewhere here where we are saying it's half. One over 2 and 2. So this is our 2 there. This is our half down here. That's our midpoint, okay? That's what we have. So we can maybe, let's call that A, B, let's call this one D. Okay, now we want to find what is its gradient. How would we get the gradient? MAB. Now MAB is equals to change in y, xb minus x, change in y. I don't know why I'm thinking of x. The change in y, y minus ya over xb minus xa, okay? Then what do we get there? We're gonna get xb, yb is 7 minus what? Minus 3 is gonna be -3 over 5 minus 4. Then it's gonna give us what? What do we get there? We get 7 plus, it's more like 7 plus 3 over 5 over 5 minus 4. Because some of you, maybe you not understand what I mean here. When you say minus, is going to give us plus. That's why I started by writing plus there. So it's going to give us 10/9, which is equals to 1,11, like that. But now let's check what we have, what we need to understand here. When you are dealing with the gradient, you don't give it as a decimal. If you even find what called, if maybe you are looking for equation of a line, you don't rush to give us the decimal. You give it as a fraction, like that. Let me just put it like that. Let me just leave it like that. You leave it as a fraction. You leave your gradient as a fraction. Okay. So now we want to understand what we call collinear points. Collinear points. Now, collinear points are points in the straight line. Points in a straight line. So these are points in a straight line. So what is it that we need to understand about collinear points? We need to know that gradient between the points are equal. The gradient between the points is equal. Okay, so what does it mean? It means that MAD is equals to MAB is equals to MDB. So sometimes what happens is that they give you, you find the gradient of, what is it? Gradient of AB. Then they ask you equation DB. And now you're like, what is the equation? Because to find the equation, I need a coordinate. So what should I do now? You already have the gradient, because gradient is still the what is the same. Okay, so that's what you must understand about what we call collinear points. So remember, when I deal with collinear points, gradient in this what called is those lines, points in a straight line. Now let's check here. Let's talk of what we call parallel lines. So what we see here, these are parallel lines. So we can say now F is parallel to your G. So this is just a line equation, line there. Let's just say here, this point here is maybe, let's say A, B, C, D, let's say E, F. Okay, now when we've got EF like that, now this one here, this is a sign that shows you that lines are parallel. It shows you that lines are what? Are parallel. Okay, so another thing before I go on here, you always have a statement when you're dealing with what is it, analytical geometry question. Now, what do you need to understand? You need to take note of the what called the highlighted points there. Like if they tell you that it's a parallelogram, if they tell you that these lines are parallel, you must know something here, because when you're dealing with analytical geometry, we know the properties of parallel lines. So now parallel lines, so A, B is parallel to CD. What do we know? What can we deduce from there? You must deduce this before you actually tackle your answer, tackle your questions. Now you're going to say MAB should be equal to MCD. So gradients are equal. So they've got equal gradients. That's the good thing about this. Equal gradients. What about perpendicular lines? Perpendicular lines, A, B is perpendicular to C, to E, F. So here, when they are perpendicular, we know that the product of the gradient should give you -1. MAB times MCD should give you -1. So these are perpendicular lines. That's what you need to understand there. So now let's check here. What can we do here? Let's find gradient of FAB. MAB is equals to change in YB minus YA over XB minus XA. Okay, then what is our XB there? What is YB there? YB is, let's take 0 minus 1, okay, over 1 minus 0. Then what do we get here? We get 1. Okay, that's our answer. So gradient of this is -1. It's 1 because it's an uphill. So another thing again about gradient is that when you have got a gradient line that goes up like this, is an uphill, so gradient is positive. When a line is down like this, going slanting like this, is actually going downhill, and M should always be negative. This should guide you when you are calculating gradients. When they ask you to find the gradient, if the line, you see that the line is sloping like this, and now you find your gradient is positive, then you need to worry now. You need to worry because your gradient must face down. Now, let's check here what we have here. We're going to say, all right, this is our gradient. Now we need to look into equations of lines. Equation of line. Now, equation of a line. So for equation, what do you need? You need gradient and a coordinate. So you need a gradient and one coordinate. So from the general equation, you say y minus y1 is equals to mx minus x1. So y minus y1 is equal to mx minus x1. Now, what do we need here? We know that for this one here, your x1 and y1, that's your coordinate. That's your coordinate. X1 and Y1, that's your coordinate. Let's try to see here if we can find gradient of AB. Gradient of AB, we will say gradient of AB, we already have it. So we're going to use n of the coordinates. So the equation of AB, so we're going to say y minus, what is our y1? Let's use the coordinate 1 and 0. Y minus y1 is 0. Is equals to m. What is our m? It's 1 in the bracket. X minus, what is our x coordinate? It's 1. X minus 1. Then y is going to be equals to x minus 1, x minus 1. That's what we have. That's equation of what? AB. That's equation of AB. But now let's try to find equation of what is it? Of CD. Equation of CD. Equation CD. But now when we are looking for equation CD, we don't have the gradient. So where do we get the gradient? We know that MAB is equals to MCD, which is going to be equals to 1. So you're just going to use the coordinate. Use the coordinate here. We're going to use the coordinate 0 and -4. Then we're going to say y minus, what is y1? Minus 4 is equals to is equals to 1 x minus 0. That's what we have there. Then what do we get there? Y minus, so it's going to be y plus 4 there is equals to x. So y is equals to x minus 4. That's our equation there. That's how we get the equation there. Now let's check the equation of EF. Equation EF. Equation EF. Now, for this one here, we know that we don't have the gradient. We have the coordinate 0 and 3, but don't have the gradient. Where are we going to get the gradient? We know that MAB times MEF is equals to -1. Now, what is MAB? Is 1. What is MEF? We don't know it. We are looking for it. It's got -1. Then we divide by 1 throughout. MEF is going to be equals to -1. Now, from there, now we use our equation, general equation, y minus y1 is equals to mx minus x1. Then what do we have? What is our y1? Y1 is 3. Y minus 3 is equals to m is -1. What is our x? What is our z? Our x1 is -0. Then what do we get here? Y minus 3 is going to be equals to -x, like that. And -1 times 0 is going to give us 0. Y is going to be equals to -x plus 3. That becomes our equation, like that. That becomes our equation of the line. Now let's look into other thing that you need to understand here: collinear points. Sorry, man, angle of inclination. Sorry, angle of inclination. Now, angle of inclination is the angle of your line with what you call the x-axis. Now, here what we have here, we have got the acute angle. Acute angle, it shows that all the lines that are up you, like I said, the gradient is positive. Gradient is positive because it's this line here. It means that the angle lies in the first quadrant. The angle lies in the first quadrant. It's below 90. That's what it means there. Then it's a positive gradient, and the angle is acute. So M should be equals to tan theta, tan your angle. So this tan theta, tan angle is going to give you gradient. Tan beta is equals to gradient as well. That's what you must know. That's the relationship between what you call, your angle and gradient. So now when you have got a line like this, it gives you an obtuse angle, and obtuse angle, it must give you negative, because obtuse angle is in the second quadrant. Second quadrant, tan is negative. That's why we are going to get what we call negative gradient. Now let's check here when you are determining the size of alpha and beta. First of all, to find the theta here, we need to do what? We need to find the gradient first. So we need to find the gradient first. So these are the points. This is 2 and 0. This is -0 and -1. That's what it means here. So it means that to find the gradient, M is going to be equals to change in y minus y1 over x minus x1, which is going to be equals to 0 minus -1 over 2 minus 0. Then what do we get here? 0 minus minus is going to give us 1 over 2. So that's our gradient. Now, when you have the gradient, how would we get theta now? We're going to say tan theta is going to be equals to gradient, which is what? 1 over 2. Then theta is going to be equals to arctan of 1 over 2. Then we find that. So we're going to say shift tan 1 over 2. What do we get? We get 26,57. 20, you round off to 2 decimal, 26,57 degrees. That's what we have as our tan there. That's our angle. Then what about alpha? Now for alpha now, we need to know that here, to find this angle here is in the second, it's in the second quadrant. In the second quadrant, we know, we can see that here, this shows us that in the second quadrant, this angle here is equal to alpha. Remember, 180 minus theta is going to give us this. So this is our opposite side. This is our adjacent side. So here our adjacent is negative 3 here. Then up here is 4 units to go up there. So how would we get it? We know that tan is equals to opposite of adjacent. So tan theta is equals to opposite over adjacent. Tan alpha, sorry. Opposite, what is it? What is opposite? It's 4 over adjacent negative 3. Then your alpha is going to be equals to arctan of that. What do we get? Shift tan negative 4 over 3. Then we get negative 53, negative 53,13. But now we are getting negative. Negative just shows us that tan is negative, but we need an obtuse angle. We need angle that is above 90. So how do we get that angle? We say 180 minus this angle. 180 minus 53,13. Because what we need is actually the what called the obtuse angle, which is going to give us 126,87. So you mustn't leave your answer like this as negative, because we are looking at an angle that is above 90. Okay, that's what you must understand there. Now let's check what's going on here. The question that we have here, we are asked to find theta. Now, how do we get theta in this case? Can we check clearly here what we have here? How do we get theta in this case? So this needs us to think. First of all, for us to get theta here, we can see that we are not given any of this gradient. We are not given the gradient, but we can find the gradient of this one. When we find the gradient of this one, we're going to find this angle first. When you find this angle, we know that this triangle that we have here, the sum of the interior angle should give us 180. So when we can say 180 minus that angle, we get we get the angle here. Or we're going to use let's find out this gradient. Then I will show you here. Then let's have what is the gradient? M dc is equals to change in y minus y1 over x minus x1. Then what is it that we have there? Y minus y1. When you are given 2, remember this is the x-axis, it starts with x, then this is our coordinate. Here, always the coordinate starts with an x, so our x is 0 there, so we're going to say you have 0 and negative 4. So what do we have here? We're going to say 0 minus 4 over 2 minus 0. Then we are going to get a gradient of 2, because 4 over 2, which is going to give us 2. That's our gradient there. Now, when we have the gradient now, we know that we can find now this angle. How would we get this angle here? We are not asked to find this, we're asked to find theta here, but we need to get this angle here. Now, how are we going to get it? We are going to say M tan, let's just call this x. So tan x is equals to 2. Then what is x? X is going to be equals to arctan of 2. Arctan of 2. We get 63,43,43. 3 degrees. That's what we get there. This is 63, comma, what is it? So now we have got 63 here. 63, comma, 4, 3. Now, when you have got 64, comma, 3, to find theta, theta is equals to, even if we don't, we're going to remember this, exterior angle is equal to sum of opposite interior angles. Sum of opposite interior angles. Exterior angle is equal to sum of opposite interior angles. So it means that here we're going to say it's going to be 80 plus 63,43. Then what do we get here? We get our answer plus 80. We get 143,43. That's what we get there. But some of you might not remember that. Remember here, when we are having sum of interior angles here of triangle, it gives us 180. And also sum of the angle in a straight line, is give also what? 180. So what we are missing is this now. So we just need to add these two to get this theta. I hope you understand. But if you don't understand, you can find the acute angle here first to say 180 minus 80 minus 63,43, we get 36,3. So you're gonna use this 36,57. Now, when we've got 36,57, a straight line, if we've got some what called 180, so you're going to say 180 minus answer, we get 143,3. That's what you're talking about there. So you just still get the same answer there. Okay. So whichever way, you must just remember what is it? The rules. Okay. Now let's try to attempt a question here, and we are looking at this question 14. Question 14. So I'm gonna start with it here, because these are the type of questions that we actually encounter in exams. Now we are told that ABCD is a parallelogram. ABC is a parallelogram. Now, when you're told that it's a parallelogram, you must think of properties of parallelogram. Parallelogram, the opposite sides are parallel, opposite sides are equal, diagonals, they do bisect. That's what you must remember always for all parallelograms. So now let's check here what we have here. We are told that what is the ABCD? A is 1, 2, 1, 2. What is it? B is 7, 2. Then D is 5, 5. Then what is the length of AB? AB, let's start answering 14,1. AB is equals to root of, remember, XB minus XA in squared plus YB minus YA squared. That's what we know. Root, what is our XB? Our XB then is 7, sorry, minus, let's keep it close, minus 1 plus, what is our 2 minus 2 squared? Then what do we get there? AB, we're just gonna get root of 7 minus 1 squared. But here now, forgot here, I'm just going to show you here, we get 6. Here, we were not even supposed to use, this method here. We were just supposed to pick, because your 2, this is a straight line. We are just looking at the distance between 7 and 1 to say from here 7 to 1 is just 6 units. We're supposed just to say 7 minus 1. Okay. But now let's move on to 4.2. 4.2, calculate the length of AD. Where is AD? A to D. Now, A to D, we can now use what we have there. AD is going to be equals to root of, what do we have? I'm going to repeat the formula here. We're going to take AD, we're going to say 5 minus 1 squared plus 5 minus 2 squared. Then what do we have there? What is our answer there? Let's just get straight to the answer. Okay, let's have 5 minus 1 squared plus 5 minus 2 squared is equal to 5. So root of that, we're getting 5 here. Now that's 5 units. Now let's move on to another one. We're going to write the coordinates of C. Here is the trick now. Here is where you start to think, to start now to apply what you have learned. Now, coordinates of C, look here, is a parallelogram. What we know here is good, it's very simple here. We have got a midpoint here where your diagonals bisect, where your diagonals bisect, where your diagonals bisect. Where your diagonals bisect. Now they do bisect at the same point. So this same, the midpoint is the same. So when you're saying bisect, it means that this part here is equal to this part is equal to this part. That's what we mean by bisecting. You're cutting into half. So here now we know that the midpoint should be the same for AC and DB. So what do we do first? We calculate midpoint. So we say midpoint DB BD is going to be equals to what is it? Remember, we say what we say, we add 5 plus 7 over 2. Then what call 5 plus 2 over 2. What do we get there? We get 5 plus 7. We get what? We get 12. So 12 over 2, we get 6. Okay. Now, what about 5 plus 2? We get 7. Then we have 7 over 2, like that. So 5 plus 2, we're getting 7, 7 over 2. So this is our midpoint. This is our midpoint. Now, that midpoint should be the same for AC. Now, here is the trick now. We are going to say MAC for parallelograms is equals to MBD. Then what is our MAC? MAC, we are going to use the code that we have. For C, since we are not given, we are going to use X and Y. We use X and Y because we don't know them. We are looking for them. So what do we do now? MAC, how do we get MAC? We say X plus 1 over 2 in the bracket. Okay. How do we get in terms of Y? We're going to say Y plus 2 over 2 in bracket. What must we get? We must get 6 and 7 over 2. That's what we must get there. So now we need to separate these two now. We separate and solve separately because we are equating this to this, this to this. We are equating the two because we need to equate them because we know that X plus 1 over 2 must give us 6. So what we're going to do, we're going to say X plus 1 over 2 must give us 6. Then X is equal to X plus 1 is going to be equal to 12. Okay. Sorry for that. X plus 1 is equal to 2. X plus 1 is equal to 2. Let's keep our question close to us. X plus 1 is equal to 2. Then we get X is equal to 12 minus 1 is going to give us 11. So X is equal to 11. What about Y? We're going to say Y plus 2 over 2 must give us 7 over 2. Then what do we do from there? We multiply by 2 throughout. Y is going to be equals to 7 minus 2. Okay, I hope you understand. We are taking the 2 here. We multiply, this side is going to cancel. Then you're taking the 2 that side. This is the one that we are saying minus 2 there. Then it's going to give us 5. So what is our C now? Our C should be equal to 11 and 5. That's our answer there. Okay, that's our answer. Let's move on again to another question that we have. Another question that we have is that what is the distance between AB and DC? AB and DC. So AB and DC, how do we know AB and DC? This is the distance that they are looking for. Perpendicular height. Perpendicular height, that's what they are looking for here. between DC and AB. How would we get that? We are going to use, Pythagoras Theorem, because what we need to know here is that this point here, we already have it, is 7, 11, and 5. It's already 11 and 5. I'll just show you here. It's 11 and 5. That's what we have there. It's 11. Okay. So what it means here, it means that when you are given 11 and 5, it means that for us to know the distance here for this triangle here is going to be 11 minus 7. 11 minus 7, which will give us 4. So what we have here is that we have a small triangle there. Let me draw this one as an imaginary. What we are having there is something like this. Then we have something like this. Okay, because our triangle is our line there is the one that we know that exists. This is our B. This is our B with 7 and 2. I want to show you something that you must understand there. 11 and 5. Now, for us to get this distance, we're going to say, because in terms of x here, in terms of x, so we're going to say 11 minus 7, we get 4. So, but this one already we calculated the distance. Remember, we calculated the distance of AB. Sorry, not AB. We calculated the distance of what? Of AD. Did you calculate AD? Yes, AD, we calculated it. So we know that AD is equals to BC. AD is equals to BC. Why? Because the parallelogram opposite sides are equal. Can you see what you are applying here? You are applying that to say distance AD is equals to BC. So this one must actually be equals to 5. Now we're looking for the smaller side there. Then what it means here, it means that perpendicular height, we can just say, maybe let's call this X. We're just gonna say CX is gonna be equals to root of 5 squared minus 4 squared. Remember, this is hypotenuse. This is one opposite, is opposite adjacent. Simple like that. So root 5 squared minus 4 squared is going to give us 3. So CX is going to be equals to 3. So, and between distance between BAB to BC is equals to 3 units. Okay, 3 units. Now calculate the area of the parallelogram ABCD. Okay, for this one here, what are we going to do? What are we going to do here? We are going to say, all right, for us to get the area here, what do we have? We've got 2 triangles here. We can take 2 triangles because this one is subdivided into 2 triangles, which is 14.5 that we are looking at now. 14.5, we are going to say we are dealing with this. And this is our base, this is our height. Or we can use this triangle here to say, okay, our triangle, we have got triangle of what? Triangle of, what is it? Triangle DBC. Triangle DBC. What we have is more like this. Let me just show you so that you understand how it look like here. It's like this. Yes. Okay, so let's look at triangle DBC. DBC now, what do we need to know? That these are build-up questions. You also face that in when you're doing questions, exam questions. They are build-up questions. So already here, what were we looking for in the previous question? We're looking for perpendicular height. This is our perpendicular height. Okay, when you're dealing with triangles, you need to have perpendicular height. Okay, that becomes your H. So what we actually have here, we already calculated the perpendicular height of this triangle. And this becomes our height, and our height is equals to 3. Then our base, we already calculated the base here because we asked to find AB, which is equal to DC. So the DC is our base. So our base here is equal to what? What was our, it was equal to 6. So it's equal to 6 units. So you've got AB. So now, but now what we have got here, you have got two triangles that are this, that are same, that are that are equal. So you need to say, all right, our area is equal to half base times what? Times height. Now half base times height, but remember these are two times that. That's what we're having because we've got two triangles there. Then it's gonna be equals to 2 times 1/2 times what? What is our base? 6. What is our height? Is equal to 3. Then what do we get there? This is just 6 times 3 because 2 and 2 will cancel. So 6 times 3 is 18. But and again, when you're looking for the area, remember it's supposed to be units squared. Here you just write units, but here because of area it's units squared. You're not given any, is it what called centimeters, is it kilometers, is it meters? We are not given that, but you just say units squared. Whatever units can be, it just have to be units squared. Okay, so that's how you actually deal with actually such questions. I hope you guys you understood this and this was helpful. Thank you so much.